Hey guys, welcome back to my CCNA 200 301 course. In today's video, I'm gonna show you some configuration and troubleshooting commands related to spanning tree protocol. Are you ready? Let's get started. You can see our topology on the top left of the screen. We have three switches that were connected in a closed loop connections. So spanning tree should have kicked in and blocked one of these interfaces to make sure there would not be any closed loop in layer 2. I'm gonna start with the basic troubleshooting command, and that is show spanning tree. First of all, you can see that this information belongs to VLAN 1. As I mentioned before, in Cisco switches, a spanning tree runs per VLAN. So you will see the information per VLAN. And if you don't filter the VLAN you desire to see the information, it will show you all VLANs. At the moment, I only have one VLAN in this infrastructure. So the output shows only VLAN 1. But if you have any number of VLANs, this command will show you this information for all available VLANs you have on your switches. The first thing is this one. So it says for VLAN 1 is spanning tree enabled, and the protocol is IEEE, which means 802.1d. And the next set of information belongs to root ID. So in this switch perspective, who is the root bridge? The priority is 32,769, which you know that it consists of one base priority, which is 32,768 plus VLAN ID. The MAC address of the root is this one, and I am the root bridge for this VLAN. And information about the hello time, 2 seconds, default value. Max age 20 seconds, again default value. And forward delay is 15 seconds, again default value. And what is my information? My bridge ID is this one. And my address is this one. Timers, aging time, and information about the interfaces. As I mentioned before, when a switch designates as a root bridge, all of its connected interfaces will have the designated port role, and they will be in forwarding state. If you want to filter the output of this command and see the information about a specific VLAN, you can simply specify that VLAN in your command with show spanning tree and VLAN and then VLAN ID. So it shows you the relevant information about that specific VLAN. The other customization thing you can do with this command is having a look at the specific interface status. So you can say show spanning tree and then interface and then, for example, gig 00, and it shows you the information about this specific interface, which VLAN it is in, what is the role of this interface, what is the status, how much is the cost, the priority number, and the type of the interface. You can get a more detailed information about a spanning tree on your switch through show spanning tree and then detail. As you can see, it shows you a lot of more information about ports, a status of that port, and etc. On the other side, you can summarize this output by show spanning tree summary. And as you can see, it gives you a bird's eye overview on the spanning tree status of your network. And again, these commands can be customized per VLAN. And if you have a lot of VLANs and you want to filter that specific VLAN, you can say show spanning tree, for example, VLAN 1 detail, or show spanning tree VLAN 1 summary. So it shows the information relevant to that specific VLAN only. Now let's see how we can tweak some spanning tree protocol configuration. The first command I want to show you is spanning tree mode. Spanning tree mode simply means what version of the spanning tree protocol you are going to run in your network. As you can see, we have three options: MST, PVST, and Rapid PVST. PVST is PVST Plus or 802.1D, and Rapid PVST is RPVST Plus or 802.1W standard. And these two protocols are compatible, which means you can have some switches on PVST and some switches on Rapid PVST. But the thing is, if you want to benefit from the Rapid PVST advantages, obviously you have to configure this on all involving switches in your spanning tree infrastructure. And MST is a kind of a standard implementation of per VLAN spanning tree protocol, but in non-Cisco switches. So if you have non-Cisco switches and Cisco switches in your network and you want to benefit from multiple instances of spanning tree protocol, you can use MST. And MST is out of CCNA topics. So now I'm going to show you, if I change the mode on this one, change it to Rapid PVST, and now have a look at the show spanning tree information, you can see that IEEE changed to RSTP now. But if I go to other switches and run show spanning tree still works. But on this one is IEEE, which is PVST, but on the other one is RSTP, which is compatible, but obviously you cannot benefit from the advantages of Rapid PVST if you configure your protocols like this. The next set of configuration commands I want to talk about are related to the timers. You remember we had three timers: hello timer, max age, and forward delays, which by default was 2 seconds, 20 seconds, and 15 seconds respectively. If you want to change that, you go to global configuration mode and you say spanning tree and then VLAN. You can select one VLAN or more. If you want to do, for example, from VLAN 1 to VLAN 100 or VLAN 1 to all the way to 4094, you can do that by adding like this, for example, 1 to 100. Okay, so since I have only one VLAN, I pick VLAN 1, and here you can say hello time and set your hello timer between 1 to 10 seconds. Also, you can configure your max age and then something between 6 to 40 seconds. And finally, your forward delay or forward time, something between 4 to 30 seconds. I personally would not recommend you to change these values with the CCNA level knowledge you may have at the moment, because changing these values requires some sort of delicate calculations based on your switching infrastructure and how many layers do you have, how many switches do you have per layer, etc. But anyway, just know about these commands and how you can change these values at this stage. Now let's see how we can manipulate a root bridge election process. It is always recommended you as network administrator, based on your network layout, pick the right switches to become the root bridge and the secondary root bridge. So if primary fails, the secondary will actually kick in and take the responsibility. If you remember, based on the default root election process, we cannot do much because all priorities are the same by default, and then this is the MAC address that breaks the tie. So we as network administrator cannot do much with that process. So we have to make some changes so we can take the control. And that change simply is changing the base priority. Again, since this is running per VLAN, we can change this priority per VLAN. To change the priority of your switch on a specific VLAN, we have to go to global configuration mode and say spanning tree VLAN. Again, you can pick multiple VLANs through hyphen. For example, 3 to 5, 9 to 11, or 1 to 100, or just pick one specific interface or VLAN, sorry. So we say spanning tree VLAN 1 and then priority. Since we have 4094 and basically 4096, considering the two reserved VLAN numbers, the increment of this value, this base value, can be between 0 to 61,440, but this has to be increments of 4096 to be able to cover that adding VLAN ID to that base priority number. So on switch 1 at the moment, switch 1 is the root bridge. So I'm going to change it on the other switch. So I go to switch 2 and say spanning tree and then VLAN 1 and then priority, something below 32,768. So I make it like 0, the least value I can set. So as soon as I make this change, there should be some reactions in terms of a spanning tree. A spanning tree will react to this change, and this switch actually will send those superior hellos. So topology needs to be changed. And from now on, I should be the root bridge for this specific VLAN. And as you can see, things have been changed. And now switch 2 has become the root bridge for VLAN 1. There are two more human readable commands that you can use to set your root primary and root secondary switches. But the thing is, in the back end, they will be changing the priority as well. So it's not a magic thing, it's just about human readability. I reverted the configurations. So at the moment, again, switch 1 is the root bridge. So if I say show spanning tree, you can see that switch 1 is the root bridge. So I go to switch 2 again, and I would say spanning tree and then VLAN and then VLAN 1 and then root. And as you can see, I have two options, root primary and root secondary. If you pick primary, switch will change the base priority of your switch to 24,576. And if you pick secondary, it goes one step forward and make it 28,762. The interesting thing about the root primary command is if the current root bridge ID is equal or lower than 24,576, it will decrease the priority of the current switch that you're running this command on by 4096. So whatever is the current root bridge ID is will be decreased by 4096 and will be set as the priority of that switch to make sure this switch will become the root primary. The only occasion that this command will confront an issue is the current bridge ID is 0, and obviously it cannot be decreased by 4096. But this is not true for secondary. So if you set root secondary, no matter what is the other switch's priorities, it will set the priority to 28,672. So if you want to make sure that a specific switch gonna be the root primary, when the current root primary fails, you have to make sure that no other switches has the lower priority than 28,672. Let's see how it goes. So I say on switch 2, I say make it a root primary. And now if I run show spanning tree here, you can see that the root has been changed. The priority is now 24,577, which has that VLAN 1 added to the base priority. And this bridge is the root bridge. So switch 1 is not the root bridge anymore. And also, if I go to switch 3 and say spanning tree and then VLAN 1 root secondary, you can see that show spanning tree will show you that the bridge ID, my bridge ID, is 28,673. So the base has been changed to 28,672. But the other switch still remains the root bridge. So based on these values, and given the fact that all other switches in my network have higher priorities, if the primary fails, this switch will be the next root bridge, because after the current root bridge, this one has the lowest priority amongst the switches. So with this setup, you can pick your primary root bridge and also the secondary root bridge. In case the primary fails, your desired switch will become the root bridge, not any other switches. Alright guys, this was our today's video. In the upcoming video, I'll be talking about some other configurable features of the spanning tree protocol. I wish you enjoyed today's video and see you in the next one.